welcome to my project.com. Let's now I am going to explain the topic multi-level DC link inverter and control algorithm to overcome the partial shading. Now I am going to explain the concept of multi-level DC link inverter and control algorithm to overcome the PV partial shading. Our main aim is to overcome the problem of partial shading of PV source, that is photovoltaic source. So here we developed a new algorithm for controlling the inverter. From this we extract the maximum possible power from each photovoltaic source. This algorithm is mainly applied in multi-level DC link inverter and also MPPT, that is maximum point power tracking algorithm is applied to each PV source. Here we implemented this inverter model and further processed in MATLAB simulating software. Partial shading of individual photovoltaic sources is connected in series. From that we reduce the current. Here PV permutation algorithm is used to overcome the problem of uneven irradiance. From this we reduces the computational cost also. Now I am going to explain the flow of this process. Initially we start this process in MATLAB simulating software. After that we design the inverter model. Here generally inverter is an electronic device that changes DC to AC. Static inverters do not use moving parts in the conversion process. Here multi-level DC link inverter is designed. Next we design the PV source, that is photovoltaic source. Photovoltaic source means generating electrical power by converting the solar radiation into direct current electricity using semiconductors that exhibit the photovoltaic effect. Then PV sources always reduces the current, and also here we used diodes in order to avoid the damage of individual PV sources. PV multi-level DC link inverter with the algorithm is used to overcome the problem of uneven irradiance. Next we go into the MPPT algorithm, that is maximum power point tracking. Here PV panels have a well-defined operating point that delivers the maximum power. Then we finally analyze the results. From this we see the results in the every scope of this flow. This is MATLAB simulating software. In this software only we implemented this process. Named is the model that we designed related to this process. This is the model designed for this process. First initially we give the voltage, that is input supply to this design. For this process we maintain the DC voltage as 400 volt. Then IGBT device is used here. This is the multi-level DC link inverter model. Here why we use IGBT device means it's a 3-terminal powered semiconductor device. Primarily it's used as an electronic switch, and in newer devices it's for accompanying high efficiency and fast switching. For each IGBT device, gate bulbs is given. This gate bulbs is coming from the PWM generator. Then in IGBT device, common point is connected to the voltage supply, that is positive supply, and the emitter is grounded. From this we use the current measurement and voltage measurement. Along the current measurement, RL load is multi-level photovoltaic cells have a complex relationship between their operating environment and the maximum power they can produce. In PV system, PV panel is designed. For this, voltage, radiance, temperature is some blocks are presented in this PV panel. Then from the diode is connected to current sensor, it's connected to the PS simulating converter. From that we conclude that multi-level DC link inverter is implemented. Then also a new method of extracting the maximum power from each PV sources to the load, and also PV sources, that is maximum possible power is obtained from this process. Thank you.